So we're going to do some more practice on some trigonometric equation examples. So here's a screenshot from online of all the different trig identities that we've covered, and the whole purpose of covering these identities is so that we can use them to solve trigonometric equations. And also later on in Calc 2 you'll use them to help you do other things. So let's start off with this example here, and if you want to, you can stop the video, try it on your own, and then start the video and see what I did. I've got two parts here, one with just the solution for the first period, and then the second one for all, and then we're going to check our answers. So when you're looking at this example here, it's quadratic looking in nature, so I'm going to set it equal to 0. So it actually looks like 2u squared plus u minus 1 equal to 0, where u is sine x. So if you like the u sub, you can try it that way. I'm going to think of it this way and go ahead and try to factor it. So I'm going to put a 2 sine x and a sine x. That's going to cover this first part of the FOIL. Now I've got the last part is negative 1, so I'm going to put a 1 and a 1, and since this sum of the inside and the outside terms is a positive sign, I'm probably going to put the positive 1 here and the negative there, and then I'm going to check the FOIL and make sure it worked, and it did. So now I've taken something that looks quadratic into a product of two things that equal to 0, so now you have the zero product property that you can play. So I can set 2 sine x minus 1 equal to 0, and then sine x plus 1 equal to 0. So you have sine x equal to a half, and sine x equal to negative 1. Those are the two trig equations I need to solve now. So what x values give me a half, and what x values give me negative 1. So I'm going to look at my unit circle, and the 1/2, that happens when my angle is pi over 6. It also happens when my angle is 5 pi over 6. So that covers this solution right here. Looking for negative 1 with the sine value. Sine is negative 1 at 3 pi over 2. So if I just wanted solutions where x is between 0 to 2 pi, I have 3 right there. Pi over 6, 5 pi over 6, and 3 pi over 2. If you want all solutions, you're just going to take the 3 solutions that we found and add the fundamental period, a 2 pi k, a 2 pi n, where k is an integer. So now let's actually check this graph on the calculator, and I'm interested in when does this have solutions. So I'm going to pull that up in Desmos, since my graphing calculator here is frozen. So I'm going to put in the equation 2 sine squared plus sine x, and I need a y equal in front. And then I'm going to also do y equal to 1. And so I'm looking for answers. Pi over 6, 5 pi over 6, 3 pi over 2. And then you can see that that is one period, so then you can just continue to add. So Desmos is actually really nice to check answers there. Let me close this. So now go ahead and try to solve these three, and I'm going to stop this and do a new recording of each one of these.